Linear search is one of the simplest and most straightforward search algorithms in computing. Its primary purpose is to find a specific item within a list of data by examining each element in the list sequentially until a match is found or the entire list has been checked. This method does not require the data to be sorted, making it a versatile option for searching in unordered datasets. Despite its simplicity, a linear search can be less efficient compared to other searching methods, particularly for large datasets, as it involves checking each item one at a time. To perform a linear search, the algorithm begins by comparing the target value with the first element in the list. If the first element matches the target, the search concludes successfully. If not, the algorithm proceeds to the next element and repeats the comparison. This process continues until the target value is found or until the algorithm reaches the end of the list, at which point it determines that the item is not present. The time it takes for a linear search to complete depends on the position of the target within the list. In the best-case scenario, the target is the first element, requiring only one comparison. In the worst-case scenario, the target is either the last element or not in the list at all, requiring the algorithm to examine every item. The steps of a linear search can be effectively represented using a flow diagram. Flow diagrams provide a visual way to map out the decision-making process and sequence of operations involved in the algorithm. A flow diagram for a linear search typically begins with an oval labeled Start, followed by a rectangle indicating the action, input list, and target value. The flow then proceeds to a decision diamond with the question, is the current element equal to the target? If the answer is yes, the flow leads to a rectangle stating, output, target found at position, followed by another oval labeled End. If the answer is no, the flow proceeds to a rectangle stating, move to the next element, followed by another decision diamond asking, are there more elements? If there are more elements, the flow loops back to the first decision diamond to continue the comparison. If there are no more elements, the flow proceeds to a rectangle stating, output, target not found, ending with an oval labeled End. Using a flow diagram to represent a linear search not only makes the algorithm more understandable, but also highlights the logical flow and repetitive nature of the process. This visual representation is particularly helpful in teaching contexts or when debugging the algorithm, as it makes the individual steps and decision points clear. While linear search may not be the most efficient algorithm for large datasets, its simplicity and adaptability make it an essential concept in the study of computational thinking and algorithms.